Okay. I'm not going to teach you C#. We'll talk a lot about it, but you teach it to yourself if you don't know it already. Now, if you've written any Java, C# is a Java clone. Microsoft won't, they won't admit that, but it is. It's a Java clone, just like Java. So, the packages are a little different, but do essentially the same things. So I want to start by looking a little bit at the website just so you know what's here, just because there's some new students here. So you guys who've been in my classes before, bear with me for just a couple of minutes. So on this main page of our website, there's a bunch of things you want to know about. So there's a list of all the courses. Each course has a course page. That's what we were just looking at for SMA. And then each lecture has a page linked to from that. And I have pages for software modeling analysis. Internet programming I no longer teach. I developed that course, and it's now taught by Deuce and Collider, and he uses a lot of the same materials. Object-oriented design I teach in the spring. Distributed objects I teach in the spring. Design patterns I teach in the fall. And by the way, if any of you new guys have registered for design patterns, it has a prerequisite of either this course or object-oriented design. If you haven't taken one or the other of those courses, you can't take design patterns. So if you're registered for design patterns and you haven't taken one or the other of those two courses, drop it. Because what happens is, if I don't recognize you in the class, I don't recognize that you've taken one of the prerequisites, I pull up your transcript, and if you haven't taken one of those prerequisite classes, I won't assign you presentations. If you don't do presentations, you fail the course. Okay, so drop it. All right, so there's a page that summarizes a lot of sample code and presentations. Page on office hours. The TA grader support hasn't totally finalized for this class yet. So this is last spring's page, this office hour page. As soon as, by late this week, I expect this to have stabilized, and I will update this office hours page with the hours. We'll take a quick peek at it in a minute. So, in fact, let's take a quick peek at it right now. So you'll find a whole bunch of handsome guys there in the times when they're available in their office hours. Typically, the TAs hold office hours in the basement. They don't do it up here on the 4th floor. There are 5 TAs and graders that will be doing office hours this semester. I asked them each to do 8 hours, so that's 40 hours of total time. That means you should be able to get to somebody almost always when you have a question. Every Friday morning, I have a help session in this room. This says in the afternoon because that's the spring session. The fall will say 9 o'clock, CST 4-201. So, and that includes this coming Friday. We'll have a help session. And I don't come with an agenda. I just answer questions. It's here just to answer questions. You'll see in a few minutes as we get going, it's hard to get questions in on my class. I got so much stuff coming at you that it's hard to ask questions. And so those Friday morning help sessions are a great place to come and get questions answered, get a kind of a wide bandwidth personal interaction. Okay, so Core Tech is where I put stuff that is common to more than one course. There's a lot of C# material, a lot of C++ material, and so on, threading materials and so on in that section. And you'll see me frequently in class when I want to bring up a resource. I may go to that Core Tech section. I've got stuff scattered all over the place. You'll see, here's the directories. Let's go to the 681. So And let's just look at the code folder. So the good news is there's lots and lots of code examples for you to look at. The bad news is there's lots and lots of code examples. Okay. Now, you don't have to, I don't think it's time well spent to go here and poke through all these folders. All of the code that's relevant to the lectures are linked on the lecture pages as we go. And so the lecture pages organize all that for you, so you don't have to worry about digging through this stuff. But it's there, you know how to find it. Project stuff. I've got some advice about getting started and so on. There's a place that you can get to upload your projects, and as it comes time to do that, we'll talk about that a little bit. I want to say make a couple of comments about the grading policy right now. Academic integrity is a major issue. All of the courses taught at SU are subject to its academic integrity policy, and let's see what that means for you. Specifically, for this class, for my courses, you may discuss your projects with me, with the TAs, and with your classmates and friends. Some courses don't like you to do that. Perfectly fine with me if you discuss the projects with your friends and classmates. Design ideas, perfectly okay to say, gee, I'm stumped on it. How do I, got any ideas about how to, but all of the code has to run through your fingers. All of the, we write documents and we write code. All of that has to come through your fingers. Specifically, you may not share somebody else's code. Two of you can't work together on one piece of code and both submit the same piece of code. If we detect it, you'll both get zeros. If you give your code to some other student and they copy it, very often, if you give them their code, they'll copy it. You do that, we detect it, you both get zeros, both the giver and the taker. Don't do that. Don't put your code on GitHub. I've had several students put their code, as soon as they finish a project, put it up in GitHub, and some other student come pull it down, change the names to their own name, and submit it as their work. Okay? Student didn't pass the course, but, don't do it, because giver as well as the taker, if you put your code on GitHub, you are a giver. Okay? Don't do that. You're welcome to put your code on GitHub after you finish the program. Welcome to do it. Good thing to do, but don't do it now. You can use any part of any of the code you find on this website. Any code I have written, you can use in your projects. And you often will. The projects, I designed them to be challenging enough so that you probably will be forced to use some of my code. Okay? You'll find a lot of that helper code in the course code. Project, help, spring. In this case, it'll be project 2, help, fall 16. Okay. And as I put stuff there, I'll link it on the lecture pages, and we'll talk about it, and I'll show you what's there. You may use documents placed in presentation folders and best project folders in this website for ideas, but only for ideas. You will write some documents, and we'll talk about that in just a second. And you're welcome. I put some samples on the available to you, linked on the web pages, so that you can see them, understand what you have to do, get some ideas about how you write them, but then you must write them. If you take somebody else's project and edit it, you will have lots of their words in your document. That's plagiarism. Anytime you use anybody else's words, quotes, every word you use from another document in quotes, and a citation for it. Anything other than that is plagiarism. And if we detect it, 0. If we detect it a second time, you go up before that. We cite you to the Academic Integrity Board. Okay, we really feel strongly about that. Happy to have you talk to people, get ideas, help each other. That is great, but what you submit has to come through your own fingers. You may not submit a modification on another student's project work. You may not work together on shared code you both submit. You may not submit any code from the internet, any. Not even Boost libraries, okay? You may not use any document text from the web without full and complete attribution. It means that every piece of text that you use is enclosed in quotes and given a footnote with the URL of the original text. You can do that, it's okay, but you got to cite it. So it's clear what's your work and what's not. If you use my code from the website, there's a courtesy that I ask you to do. If you use my code and you change it, you list yourself as the author and me as the source. If you don't change a character, if you don't change a single character, you just leave me as the author. The issue is this. I have, in years past, had somebody come to me and say, I've got your code, it won't even compile. And I look at it and somebody left my name on it and did horrible things to the code, you know, made a mess of it. So if you change a single character, you're the author. So you know, people that want to complain about it will descend on you, not on innocent old me. Okay, I'm not saying all my code is bug-free. Okay, we'll see exactly why all code is not bug-free all the time. Okay, but that's a protocol that I insist you use. Do not place any project submission materials on GitHub or other public website until you've graduated from our program of study. Should you and one or more other students submit the same code, other than my code for the website, you will all receive 0 for the part of the code that's identical, and a grade no higher than C for the project. That's a 2.0. Don't do that. And if you do it a second time, you get reported to the Academic Integrity Board. You know, almost all of you don't do that, but there are always 2 or 3 people in the class who do it. And you say, he'll never catch it, and you know, maybe we won't. But maybe we will. If we catch it, that almost certainly means your grade for the course is going to be much less than you want. And when you step out for an interview, okay, won't look good. Also, remember that when you leave the program, you are going to step across the threshold for an interview. If you have done everything yourself, you'll do just great. If you've used you've taken an awful lot of help from your friends and buddies, and haven't done all. When you step across the across the threshold, in 2 minutes they will know. I guarantee you, in 2 minutes they'll know whether you know your stuff or not. I used to do interviewing. I worked in industry for 30 years, and I managed several groups, and I did a lot of interviewing, and I guarantee you, you can tell in 2 minutes if somebody knows what they're talking about. If you know an interview, you know in 2 minutes. So the way to do that is you just do all your own work. Suppose you get to the deadline and it's not all done, so you submit. It's not horribly important that you have met every single requirement. If you have 1 or 2 of the hard requirements you haven't met, you won't get credit for it, but you get a perfectly good grade. You can get what amounts to an A grade on a project without meeting every single requirement. But you need to do all that work. There's some policy that I have about grading. I accept projects that are late. I charge you a point a day for the first 4 projects. The last project, because it's submitted right at the end, we charge 5 points a day for late projects, simply because we have I have a very small amount of time to get my grades in the registrar. Your last project is a big architectural report, which we'll talk about in just a minute. It takes me a long time to grade them, and I grade, the TAs don't grade them, I grade the last project. I do all the grading for the midterm, and I do all the grading for the last project, because I want to know what you can do when I assign your grade. And it takes me a long time to, right now we have 120 people registered for this class. Maybe after I terrify a few people, it might get down to 100 or something like that. But still, a lot of projects to grade, and I have a very little amount of time to do it. So you would lose 5 points a day for that last project in late fees. One last thing. On projects that you submit, we'll see when we look at the project statements, we'll see that there are requirements. 1, 2, 3, 4, 5, 6, 7. You get credit for requirements that you demonstrate. You are obligated to demonstrate those requirements. If you don't demonstrate them, the output of your program doesn't demonstrate them, then you don't get credit for it. You come to the TA and say, look, I did it, here it is, I did it. And the TA say, show me where you demonstrated the output. You say, well, I didn't put it in the output. You don't get any credit. Okay. So, so let's go back and see where we are. So, grading policy, help sessions, yeah. This stuff that I'll let you look at. For example, there's a section on code smells. That's a great term. I love it. Coined by, I think, Kent Beck, who is an agile programming kind of guy. And what code smells means is these are things that you look at and say, that's a flaw in that code. He's got a whole list of them. You go look at that, go look at the link. And if you're going to write good code, it helps to understand what isn't good code. And the code smells help you do that. Okay, there's a blog that has entries that are occasionally, a lot of times there'll be something I want to talk about that is a little too detailed to get into all the nuances in class, and so I might write a little blog post about it. Or last fall in this class, we built a NoSQL database. We didn't use one, we built it. And so I wanted to make clear to everybody what constitutes a NoSQL database and how you might go about it. So if you're interested, go take a look at the blog. You'll see. So on. I'm going to talk a little bit about parsing during the course, and so there's a whole bunch of blog entries you're invited to take a look at. Okay, and a few other things. ECS. So here, one of these days you'll have your own student picture here when you graduate, and you're smiling, your family's here, and all that. So you'll get to have your picture on the website. All right. So with that, let's go back to the course. So we're concerned with modeling software and implementing it. So especially we're interested in large distributed systems, including the architecture, design, and implementation. Now, we're limited to how big the systems are, that we can implement, but you'll be surprised how big systems you can implement, okay, with some help. And you'll get lots of help. To help us understand that, we introduced diagrams. We'll talk more about these in just a few minutes, but there's a bunch of UML, Unified Modeling Language diagrams that we use to help represent systems we're interested in, and we'll talk about today why we want to do that. We have 5 projects that are required. They're progressively more challenging. The first one is a document, a concept document. I call them operational concept documents. So I'll give you a description of a system you're going to develop in Project 2, and Project 1 says, go write a document for Project 2. And in Project 4, we implement a bigger, more interesting system. And in Project 3, we have a document that says, go describe that system. And in Project 5, we have a document that describes a big federation of clients and servers. Okay. So we expect, when we're done with the course, to be able to design and implement relatively large, complex systems, some proficiency with C# and the .NET framework, experience with systems that have multiple packages. If you don't know what a package is, we'll talk about it today. That use threading, graphical user interfaces, interprocess communication. We're going to do all this. And preparation for more advanced courses. The syllabus describes, oh, by the way, before I get to the syllabus, there's a text required for the class. C# in a nutshell, you want the C# 6 in a nutshell. This just talks about C# and the .NET framework. It does not talk about software architecture at all. So it talks about maybe a third of the content of this course. I will, in my notes and presentations, talk about all the other things. You'll have documented for you all the other things that you need to capture from this course. But there's far too much detail about C# and the .NET framework for me to tell you all that stuff in the class, and so you need this book. And you want C# 6, not C# 5. A really great book. It's a terrific book. I have some notes and references from some other things, CLR versus C#. These are interesting, interesting books. Don't expect you to go out and buy them, but they're related. There is one I want you to think about a little bit. This book is called Writing with Style. It's the best book on software design I ever read. And it has nothing to do with software. It was written by John Trimble from University of Texas at Austin, who teaches courses on Shakespeare. No, he doesn't. Or he used to. I think he's retired now. And he wrote this book because he required his students to write expository essays on parts of Shakespeare's plays. So an expository essay is a critical analysis, well-constructed, well-thought-out, well-organized analysis of whatever the topic of the paper is, and in his case, Shakespeare's plays. So he wrote this as advice to help them survive writing these essays. He said most of the students, or a lot of the students who came to him, couldn't write. Didn't know how to write. So he wrote this book for them. And it's all about organizing your ideas and structuring things and paying attention to the user and what the user needs. And that sounds like software to me. You know, both software and a critical essay are mind stuff. The structure is what you conceive in your head. It's not a fixed, not some physical law that told you it has to be that way, okay? It's mind stuff. But it's constrained by syntax, by the context in which it's written, by convention. It's writing software is very like writing a critical essay. I love this book. Little thin book. You can take it to bed with you, read for half an hour every night, and a week and a half you'll be done. I read it myself about once every 2 years. I like to write. I think I do it reasonably well. And I've looked at a lot of books on writing, and most of them stink. Strunk and White is a famous reference for style. And it's written with awful style. It's terrible, hard to read, awful. This guy is funny, clear, brief, gets right to the point, very well organized, and he helps you do all those things. So, highly recommended. I had a student, really interesting young lady, who was a civil engineer, came and took one of my courses, fell in love with software, did a dual master's program. She did a master's in civil engineering and then did a dual master's in computer engineering. And then she went to work for Autodesk writing, guess what, software for computer design of civil engineering systems. Really smart young lady. She sent me an email a while. She had moved to a different company. She sent me an email and said, you know what, I'm just starting up a new team lead, and you know what I'm doing? I'm forcing my whole team to buy Writing with Style. Okay. So, anyway, it's a hang-up of mine. I love the book. I think you ought to think about getting it. All right. So, the syllabus. And you'll see you'll see some stuff about architecture, a lot about C#, quite a bit about structure. There's architecture and structure stuff throughout all of this. We'll get to a lot of that. There's no class a week from today. That's Labor Day. We celebrate Labor Day by doing no labor. Go figure. Whoops, didn't mean to do that. So let's go to page. So here's the first lecture page, and we're going to spend a little time with this today. Each lecture has a page, and they all have links to either presentations or code or whatever. So this has a link to the syllabus. There are 5 projects and 1 exam, a midterm exam. There's no final exam in this course. The midterm exam serves both. And we'll look at each of the projects in just a minute. I have some advice about getting started. I think you ought to read it. There's some resources. For example, here, the first thing you're going to do is write an operational concept document. So here's a resource, SMA Operational Concept Document Guide. So just, telling you, hey, here's what you're trying to do, here's why you're trying to do it, and here's some examples to give you some help. Another resource for you is, why am I getting that? Because why am I getting that? Oh, I changed that directory. Let me do this. That should, let me go. I have it on this machine. I think I changed the directory where it is. I'll have to fix that link. Are any TAs here? Yes, so let me pull this up. I will make sure that the Color server has the links that you want to see. So this is a private term, and you'll see I have the question I asked and my answer to the question I asked, my answer to the question, on and on and on and on. Good idea to look at these early because they give you an idea of where we're going with the course. What's expected of you. You can see from the exam that you got to write some code on the fly. You got to answer questions. Every semester, I create 4 midterms. You know, look around you, you're all packed together. And, you know, I know most of you are honest people, but I don't want to strain your ethics. It's so easy. Oh, like, what's this crap? Let me see. Okay, it's so easy to do that. So I pass out exam 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And 2 is just not a rearrangement of one's questions. They're different questions. They are. And these exams that I put up for you to look at are every bit as similar to your exam as the guy sitting next to you. They are, I promise you. So there's 4, you know, in the morning section, 1, 2, 1, 2, 1, 2, 1, 2. In the afternoon section, 3, 4, 3, 4, 3, 4, 3, 4. Okay, that's the way it is. So there's some help, and also these are pretty good things to look at when you're preparing for an interview. The question, I've had lots of students say, you know what, they asked me a question just like what was on your midterm. Okay. So it's a resource for your pleasure. Okay. And I have that bad link. Send me send me an email about that bad link to the midterm, and I'll fix it. So you'll have links to all the midterms for last year. Now let's talk about the projects a little bit. Here's project 2. So we're going to build a test harness. And you may say, what the heck is a test harness and why are we going to do that? And, you know, it'll become clear, but it'll take 2 or 3 lectures before it's really clear. But you'll see that in the purpose section, I kind of describe the context for the project, and then there's a bunch of requirements. 1, 2, 3, 4, 5, 6, 7, 8, and these are grades that this, question 5 is worth 3 points. Okay? You'll discover in the grading that the functional part of what you write is worth much less than half of the score for the project. You're graded on its structure, on its style, on its design, and on its functionality. All those things. Next time we'll look at the grade sheet and talk about that a little bit. But anyway, there's a whole list of requirements, and each one of these things, everything that has a shall, you have to demonstrate. If you don't demonstrate that shall, you don't get those 2 points. So we're going to build a test harness. And this is a single local little test harness. The idea of a test harness is that it allows you to automate testing, the kinds of testing that can be automated, and if we have time, I'll talk about that a little bit today. Project 1 just says, go write a document about Project 2. My purpose is to get you to think about what you're going to do before you ever touch the keyboard. So we think about the project purpose and its typical users. How is the user going to interact with the system? What are their goals? What are they trying to get out of the system? Ways to make the user interfaces effective. How to partition the processing into packages. One way to think about it is to say, what tasks does this program have to do? Well, it has to do this, and it has to do this, and it has to do this. Every one of those thises become candidates for a package. They may not result in packages, but they become candidates. It's a way to start thinking about what are the parts that I need for this program. You'll provide package diagrams and so on. And how do I present results to the user, and what important events and what's critical about this processing. What am I going to have trouble with? How am I going to show all that information to a user in some, so my program is going to generate a lot of data. How do I turn that data into information for a user? Data is almost worthless. Information is priceless. How do we do that? I'll give you an example today if we have time. So project one just says you're writing an Office document, Word document with Visio diagrams. About you could use Open Office or WPS or whatever you want to use. Shall explore and describe the user interfaces you provide, shall partition processing and release top-level packages, shall describe uses and responsibilities, activities and events. We talk about uses. In your undergraduate courses, you were probably exposed to use cases, but they lied to you. What they told you were use cases are really design cases, not use cases, design cases. We don't care about design cases. I don't want to see design cases. I want to see use cases. How are users going to use this? I'm going to make this really clear to you next lecture. Shall use both text and diagrams for the descriptions above. Every time you put a diagram, you have to have text that says, here's why this diagram is here. Here's what this diagram is telling you. Here's the conclusions you have to draw. So why is this diagram here? What is it telling me? What conclusions can I draw? No, Cortana, I don't want to know about the weather. Thank you, Cortana. So nice of you. Okay, so you're beginning to get the idea. So project 4 is going to be a remote test harness. So what we're going to do is take the test harness we developed in project 2 and turn that into a server that we access through a message passing communication system, and our clients have graphical user interfaces. We'll do the GUIs with Windows Presentation Foundation. We'll do the communication with Windows Communication Foundation frameworks, really nice frameworks. So we're now building a client-server system. Multiple clients on a single server, or maybe we'll get fancier than that. Who knows? The communication will be peer-to-peer. And if that doesn't mean anything to you, it will before too long. Project 5, by the way, I'll put the grade sheets for each of these, and sometime we'll come back and look at the grade sheets and so on. Project 5 asks you to develop an architecture for this system. This is a collaboration, a federation of servers and clients intended to support the collaboration developing software. So we have a repository server, we have a test harness server like we built in project 4. We have clients, we have this collaboration server is a management information type server. Now we're not going to build the software. We will have built this, a prototype for this, but we won't build the rest of it. You will build some little prototypes as part of this architecture, but here what we're doing is an expansion of the operational concept document into a fully formed architecture for this federation. That's what we're going to do on Project 5. And by now you're saying, this guy's a wild man. You gotta be kidding. You think we're going to do all that stuff? And the answer is, yep, I do. Yep, I do. And we'll sheets and stuff when we get a little closer. So now ask a very strange question. What's a program? What an odd, peculiar question to ask in a graduate course on software, in the software development sequence. To ask what a program is? You don't know what a program is? Well, the interesting thing is that it's lots of things. So here's some. It's a sequence of machine language instructions. It's an execution image that may load dynamic link libraries either by default at load time or on demand as the program executes. It may be source code. I tend to think of programs in terms of source because that's what I'm always working on. It may be an application that we run on a device of some kind, one file stored in a directory, a set of communicating threads, a process interacting with the operating system and the rest of its environment. All those things are different aspects of what a program is, and we're going to be interested in most of those in this class. Not so much this one, but we'll definitely be interested in all the rest of them. So program structure has to do with several different things. So one aspect of program structure is the way the program interacts with its environment as it gets its inputs through a command line and provide its output to a terminal. Does it accept input and display outputs in a graphical user interface? Does it accept requests and supply results to other programs through operating system and web services? Does it interact with hardware devices using device drivers and enqueued messages? Those are all parts of program structure. It also has a physical and source package structure, may consist of a monolithic executable with one or more threads running. It may be composed of an executable that loads shared dynamic link libraries. It may be built out of plug-in components. All of these are structuring things we're going to talk about in this class. Each program has source code package structure defined by the source code packages that make up the program. And if you don't know what a package is, I'm going to tell you in just a few minutes. Types and global functions that make up each package, the network of dependencies between, those are all structural issues, different kinds of structure. And we're going to be interested in all of that. So, what is a program wasn't quite so simple. Software systems. So, software systems are things like client-server systems, model view controllers interacting with web services, peer-to-peer systems, server federations. All of these are different structures. So, something you're developing may be code for a single process, but it may be a whole bunch of processes, maybe a federation of processes running. So those are all structural issues. Okay. So what is a program? All those things. And we're going to be interested in that. And software size matters. So let me skip over the words. You can read them. I'm going to talk about software size in terms of source lines of code. And a lot of people will tell you, that's so inaccurate, it's almost meaningless. And they'll say, go use function points. IBM guys will tell you, use function points. Much more accurate way of describing the complexity of a program. Problem is that it'll take you a day to count up the function points in one small program. I can go to a whole repository of code and in a couple of seconds get the source code lines of count, bam, immediately there it is. So source code lines of count are an easily accessible, only modestly accurate measure of program complexity. We'll have other measures that we'll talk about and you'll see, but let's today just put aside those reservations about, gee, source lines of code. Yeah, I may have 5,000 lines of code, simple, trivial stuff, and another 1,000 lines of code. They're really complicated. It's absolutely true. But let's put that aside. So for academic programs, a small project might have 200 lines and a large one might have 50,000 lines. It's kind of the range for an academic project. If we insist that a page of code should have about 50 lines, and that says we have 4 pages, and this says we have 1,000 pages. How are you going to understand 1,000 pages of source code? How are you going to do that? And the package count may go from 1 package to 50 packages. A professional development project typically will go from 10,000 lines of code to maybe 50 million. The Windows 10 system is about 90 million lines of code for the kernel and the flurry of tools that surround it. So that means that the page count is 200 to 1 million pages of source code, and maybe 50,000 packages max. How are you going to understand that? How could you possibly understand 1 million pages of source code? The answer is you're not. No way, Jose, not a chance. So what that says is that we have to have ways of describing and reasoning about programs that are not just source code. That's where the diagramming techniques and the concept documents come into play. Trying to understand how we can think about, reason about, and develop strong architectures for things that are going to be really big. Can't do it with just source code. Need a lot. Source code is important, but even 1 million lines of code, you know, there's a lot of stuff. No way are you going to know that whole, you know, is anybody going to know that whole thing in detail? I write code. I've been writing code a long time. I've been writing code since 1963. In all kinds of languages, and some weird languages at the beginning, and lots of C and Pascal and Lisp and tons of C++. I love C++. A little bit of Java, a fair amount of C#. Lots of code. So I write about 300 lines of code a day, and what that means is that I have done the design for what I'm going to implement today. Then I write the code, and then as I'm writing the code, I do construction testing. Construction testing works this way. I add a little piece of code, and I add a test and compile and run it. Add another little piece of code, compile and add a little test and run it. And that does 2 things for you. One is that when something goes wrong, you know right away where it is. And the second thing is, really good thing, it's always running. Your code is always running. I've had, on occasion, come across, seen a student in the hallway and say, hey, how are you coming on project 2? And I say, great, I've written all the code, all I got to do is test it, and I know they're going to fail. Can't write code that way. Can't possibly. That person was, I'm sure, hunched over his laptop at 5 o'clock in the morning, tears of frustration running out of his eyes because nothing would work. Stuff was going on. The person had no. What you want to do is start with a little shell that'll get up and going and does almost nothing, and then you add a little bit to it. I write about 6 or 7 lines of code, and I compile and run. Write that, test, compile and run. Write 6 or 7 lines of code, little test, compile and run. Again and again. It's always running. So what that means is that when the deadline to submit comes, even if you haven't met all the requirements, you can pack it up. There it is. I'm ready. It isn't the end of the world if you haven't met every requirement. You won't get the points for the requirements you didn't meet, but you can get an A on that project without meeting every single requirement. You can. But if you are sitting there having attempted to implement everything and nothing is working, you're nowhere. So don't let that be you. Okay. So anyway, I write about 300 lines of code. So for a program, 300 lines of code a day. Now maybe what my customer wants is not a program that has construction tests and documentation and code, but he wants a program product, meaning there's a specification, a design document so he can maintain it, and unit testing, so he has some confidence that it's really correct. Factor of 3 effort. Takes 3 times more effort to do this than to do that. Now maybe what my customer wants is not a program, but a program system. A set of cooperative processes that have to share a common communication format and be integrated together. Takes a factor of 3 to go from here to here. Almost certainly what your customer wants is a software programming, a software system product. 3 times 3, factor of 9. More effort. So it says my 300 lines of code went down to something like 30 lines of code. And yeah, I'm a graybeard, so I sit in meetings, I help entry-level people and stuff like that. So it's really about 20 lines of code. That really is about the industry standard. 20 lines of code a day for professional software systems. I worked for a very good engineering organization. We were building radar software, very well-run organization, and that's about what we were putting out. We use 20 lines of code a day as a sanity check on our costing. Okay, so with that in mind, let's see what that implies. So let's suppose we're going to build system of about a million lines of code. A very modest-sized professional project. Million lines of code, modest-sized professional project. So that says that at 20 lines of code per day, that's going to require 50,000 person days of effort. If I figure 2 weeks of vacation, 5 days a week, we work 5 days a week, 10 days of holidays and sick time for a person year offset by 10 days of overtime, that results in about 200 person years for this project. So if we have a staff of 50 developers working on that project, that means it's going to take us 4 years to complete that project. A million lines of code, 1,000 packages, 50 developers, 4 years to complete. Software size matters. We're talking about things that have nothing to do with what you did as an undergraduate in your programming courses. You weren't developing code. You were writing little toy exercises. In this course, you're going to write code. With my help, you'll be using some of my code along with yours, but you'll be writing code. So software size matters. I want to talk about packages. So let me give you a brief summary of packages because I think I'm going to run out of time. Yeah, because I got one other thing I want to do. If we have time, we'll come back and talk a little more about packages. But in a nutshell, a package in C# is a single file that has prologue comments and has a test stub, has a main that will execute a construction test as you're building that part of it. And it has directives around that main so that simply by going to the compiler and telling it define that string, it compiles the main, or if I don't define the string, it doesn't compile the main. So I can put that package together with other packages and compile them into a program. Because a program can only have one main. Code for a program can only have one main. So this allows me, without changing a character in my code, to run my package standalone or to combine it with other packages into a working program. And it has the overriding benefit that somebody, if you want to use one of my packages, you can take it and you can define the keyword that enables the main and run it and see what it does. Okay. So let's take a little look at something. So, just to give you an idea. So, I have used in my classes code analysis tools for a long time. I had one that I used for a long time, worked real well, but it was a little hard to use because use it from the command line. You had to CD around a whole bunch of whatever directory you wanted to test. And so I added a user interface to it last summer, and I broke it. And it wasn't, it had a couple of, it wasn't working quite right. And so this summer I said, okay, can it? I'm going to do it right. So I built a code analyzer. And the way it works is like this. So I built it using an organizing principle, and that is that I want to be able to browse for directories where I'm going to get to the code, but I want a lot information coming out of that analysis. And it would be difficult to squeeze that into a user interface. So what I'm going to do is I'm going to set the properties and the directories and the code I want to analyze, and then in a console I'm going to see what it does. And I also write this to a log file so you can print it out and save it or whatever you want to do. And so let's go to the top of this folder. So let's browse and let's go to repository, code analyzer, good. So let's open it. And so let's get it out of debug mode, put it in results mode. And let's just run, let me run slocks. So what I'm going to display here is just the files that I'm analyzing and their number of lines of code. So let's just run it. So this is a program I wrote this summer to analyze your projects. It works for both C++ and C#. And here I am reporting on things that might be questionable. This is public data. I'm using some structs here, and we'll penalize public data except if it's in a struct and you don't pass that struct out anywhere. This is just an implementation detail, doesn't matter, that's okay. But public data in a class, something that should be private, is not okay. So, but anyway, let's go look at our sloc count. So here's the files. These are the packages in this code analysis project. Abstract, syntax tree, executive, blocking queue, file manager, file system. There's some test code. The window, which is this guy, some grammar helpers, loggers, and stuff like that. And there are 10,308 lines of code in this summer project. Okay? This is not your undergraduate instructor's project. Okay? It's not a little toy. So size matters. This is what we need to deal with, what we're trying to deal with. This happens to give you a bunch of, so if I select metrics display and take off the slots display, what I see here is a list of all the metrics, the file for each function, its size and complexity. What's happening, you're seeing it parsing, what it's doing is doing all the parsing with each of those files. Here comes the metric information, and so, it lists the line. Here's the line where it occurred in the source code. Here's the size and lines of that function, and here's its complexity. I measure complexity by the number of scopes in your function. So the minimum complexity is always 1 because that function has its own scope. But if it has an if, curly braces, for, curly braces, while, those are all scopes, and then it'll add to the complexity. It becomes very difficult to test and understand a function whose complexity is larger than 10. So you will lose points on your code if your complexity is more than 10. It's hard to understand and test code that's too big. You'll lose points from your code if your functions are bigger than 50 lines of code. Now, I would have lost some points here. I'm doing, parsing code grammars are one of the most complex things you can do. So, but over probably to amuse myself in times of boredom, I will go and refactor some of this, and within a month or two, I'll meet all of the metric requirements. But the reason I'm showing you this is to give you an idea of the kinds of complexities, the kinds of things you will deal with professionally. I talk in the operational concept document, I talk about organizing principles, and there's several at work here. One of the organizing principles is that I am going to select parameters and the working set in this GUI, and then all of the output will come out on a console, and I log it all. So every place I go and analyze, I drop a log file. So what we're doing when we're analyzing is we go to some path and we analyze everything, every directory rooted at that path. So for example, let's come up to the top here. We were analyzing on my drive here, SU folder, repository, code analyzer. That was our root path, and every directory under that we're visiting. And we're saying, I want to analyze header files and implementation files for C++, and I want to analyze C# files. And give me metrics. I want results. My logger will let you show results or demos or debug. So the organizing principles say I want a console application that I can run just from, when I'm in some directory and I'm looking at your code, I want to be able to just run the console application. But the GUI is setting up all those parameters and letting me easily change it. So that's an organizing principle. And the presentation of data is very well, I spent a lot of time thinking about how this should be presented. There's a lot of information coming out. If I dropped out raw data, it would mean nothing. It would be worthless. Okay. So, by the way, this tool and source code, the tool itself is there's a directory in 681 called the source code directory, the project, the course directory called Code Analyzer, and you can find the execution images there and run it on your own code. Before the TAs run it on your code, you can run it on your own code yourself. Okay? Good idea, right, Mahesh? But the source code is also in the repository, and you can look at it and see how it was designed and implemented, if you want. Okay, so and I'll come back and talk about various aspects of it, but I'm just what I'm trying to do is open your eyes to, this is what software is. This is what professional development is. So we'll come back and look at packages, but I'm going to do that next time because we're getting close to running out of time. We end at 5:05. So I want to talk a little bit about getting started. So I love this quote from Arthur Ashe. Arthur Ashe was a tennis player, very well known. About 10 years ago, he died of a heart attack, surprisingly. Very great physical condition, but he just dropped over dead from a heart attack. Good guy, though. Start where you are, use what you have, do what you can. Great quote. That applies to you in a major way. How do I get started? It's always a matter of stepping off, taking that first step. Start where you are. You don't know everything? That's okay. Start where you are. I know some Java, so I can use that. Help me. So, as you're learning, as you're writing OCDs, you should be pulling up Visual Studio and playing around with C# and observing how it's related to Java if you've had a lot of programming experience with Java and so on. So let's talk about, there's some advice in this getting started that I'm going to maybe look at sometime. I would like you to look at it. But basically it says you really need to come to every class. These classes will be taped. And some students decide, I'm not going to come to class, I'm just going to look at the tapes. And maybe every once in a while they do actually look at the tape. Class divides into those people who come to class and those people who think they're going to look at the tapes. Grade divide on the midterms. If you want an A or an A minus, you come to every class. If you don't come to every class, very likely you're not going to get an A or an A minus. Every Friday morning at 9 o'clock in this room, I have a help session. And it's wide open. I don't come with an agenda. You just ask questions, and we have an open-ended conversation. Right? Mahesh was a student in OOD last spring, right? Yes. He came to most of the help session. Was it useful?
Yes. Very
turn around and look at him and say, it wasn't useful. No, it's okay. You thought, but I think they're very useful. So do it. You will too. I promise you, you will. Okay. Let's pull up the OCD study guide before we quit. So we're going to quit really soon now. You owe me, if I can get my phone to, 10 more minutes. So let's take 10 more minutes and talk about the operational concept document. So the purpose of the operational concept, this is what you're going to do in your first project. Purpose is to disclose to a development team and its project management the concept that binds the development together. It is not a spec. You know, the guys who teach you software engineering say specs are immutable, they never change. We develop the specs and then all the development flows out of that, and they lie to you. Specs do change. Neither the customer nor you have perfect foresight. The specs do change. You need some rock to stand on, and that's what a concept document does. It's supposed to be a clear description of here is what we're trying to do, here's roughly the way it works. So, what is the application's purpose? Who are the users and what do they need? How will the application be structured? Are there other organizing principles? So, you know, we talked a little bit about organizing principles when I was showing you the code analyzer. Is the project feasible with a reasonable budget and schedule? I've had a student in that part of his OCD say, this project was totally unfeasible. There's no way we can do the project in the amount of time we got. And of course my response was, you're just trying to get 8 hours of sleep a night. Okay, it doesn't work that way. You're a grad student. What should we be worried about? So here, in that analyzer project, for example, one major concern is how am I going to present that information? And how am I going to support these various modes of operation? I want to show metrics data. I want to show debugging data. I want to show demonstration data to show you how am I going to do that? So those are all issues. For some programs, the issues might be human life. If you're designing a flight navigation system for a Boeing 797, human safety is a major concern. If you're designing a banking system, financial security is a major concern. In our projects, money and health are not the issues, but we do have critical issues to talk about. So here's a typical outline. Here's a suggested outline. You have to follow it, but the OCD outline has a cover page. They all have cover sheets. Got to have it. It has an executive summary, and the executive summary does not say what you did. It says what you found. In other words, this is for an executive who isn't going to read the rest of the document, and they want to know roughly what's this all about. And so your obligation in executive summary is a quick summary of the concept and a quick summary of your concerns. Where are the problem areas likely to be? An introduction, and then uses. Now, these uses are not, so you were taught use cases, and they lied to you. They weren't use cases, they were design cases. I'm not interested in design cases. These are use cases. How are people going to use this system? What are the goals? How are, what kind of information are they going to come away with? Not what kind of data, what kind of information are they going to come away with? And I have an example uses that we'll look at in the next lecture or two. I think that'll nail that for you. You'll get a really good idea. Application activities. So how is the processing going to flow? What's going to happen here? So for that code analyzer, the activities were file manager is recursing through a directory structure, finding files that meet a pattern. Each one of those files is processed with a rule-based parser that tokenizes and does grammatical analysis based on these rules, and builds an abstract syntax tree to hold all that parsing information, and then the displays process what's in the abstract syntax tree to provide the slot count and the public data count and the global data count and the metric information and so on. All of that is in the abstract syntax tree. So those are activities. That's a description of activities, and we often represent that with an activity diagram. Partitions. What are the main parts? What are the primary top-level packages. What are they going to be? And typically, once you've thought about the activities, you say, okay, here's the tasks I got to do. This task, I got to do this, I got to do this, I got to do this, I got to do this. And each one of those thises becomes a candidate to be a package. I'm going to search a directory for files. There's a file manager package. I'm going to parse each file with a rule base. There is a parser package and an actions and rules package. I am going to store that information in a syntax tree. There is an abstract syntax tree package, and so on. Critical issues. Think about critical issues for the application as parts, and make an issue list for each one. Please don't cite trivial issues. This is not, the sky is falling, the sky is falling, the sky is falling. You know, in this country, there's a little kid's tale, fairy tale or something about, I'm not pulling the name out of it now, but Chicken Little. Chicken Little ran around the barnyard screaming. An acorn fell on his head and he ran around the barnyard screaming, the sky is falling, the sky is falling. And the moral of the story is don't get overexcited. You know, nothing. It's cool, guys. So, but, you know, don't cite trivial issues. You know, people will say network performance is an issue. Network performance is never an issue. Networks are so fast these days. You know, even for our project 4, where we're communicating back and forth between clients and servers, networks aren't the problem. It's the processing we're doing on a server that's the problem. Critical issues are often associated with safety concerns for life, with medical systems, wealth for banking, information security or reliability, complexity of the application. Complexity is often a critical issue for us. Loading for things like Project 4, server loading, and so on. So, and now you are asked in the Project 2 statement to do a couple of small little prototypes. Write a little bit of C# code. This is to get you writing C# code early. And you'll discover if you come to the Friday morning help session, once, I knew there was something I was forgetting. For this course, you will need to use Visual Studio 2015. I write my code using Visual Studio 2015. If you have an older version, a lot of my code won't compile because there's new features and the like. You will need a laptop. Yes, there are computers in the computer lab, and they're intended for you to use. And IST has buckled them down so hard that they're almost useless. You wait 10 minutes while all the policies get, laid down on the machine, and then you discover it keeps saying, no, you can't do this, no, you can't do that. You got to, IGS put a machine on my desk. First thing I did was pull it down, put it on the floor, bring in my own machine. It wasn't all locked in. So I think you'll need a laptop. And Visual Studio you can get for free. I'll show you maybe next time how you can get Visual Studio for free. It's really simple. It takes about 2 gigabytes to store disk space. Okay, so you need quite a bit of disk space, free disk space. So you may have to throw out some of your Facebook stuff and some of your music and all. Don't throw away your music, but your other things you may have to throw out a lot of stuff. Let me get back to the prototyping. So as soon as I'm sure that most of you have Visual Studio installed, that Friday help session, I will come in and we will interactively write a little bit of code. We'll start one of the prototypes. Okay. And that'll help you get going with Visual Studio, help you get going with C#, and hey, a free 2/3 of a prototype. Cool. By the way, I saw one of you Indian students doing this. The Indian yes in this country means no. This means no. This means yes. So
I had an Indian student who came and asked me a question when I first, first had lots of Indian students come and ask me a question. I answered it. I did this, and so I answered it a different way. He's saying, "No, I don't understand." I answered it a different way. He's going, "Yes," a little more emphatically. I answered it a different way. You'll confuse the heck out of it. This is yes. Anyway, so operational concept documents.